Hi friends, today we're going to talk about mathematical modeling notes. Mathematical modeling is just another way to say graphing. We're going to be looking at other types of modeling a little bit later in the year. So the first type of mathematical model, or graph, is a line graph. And we use this to show patterns and trends between the variables. If you have a line going up, that means that there is a positive or an increasing trend. If you have a line going down, that means it's a negative or decreasing trend. If you have just a straight flat line, there is no trend between the variables, meaning nothing is changing. We use this to represent continuous data. So it makes sense to have numbers or data in between the data points. Even though it may not be an exact value that you tested, you can still make a prediction based on your trends. You want both axes to be quantitative, or numbers. Here you can see some different types of line graphs. Both of our axes have numbers on them. There's different things that we do with the data points. Some of them we have a line of best fit. Some of them we have the dots actually connected, and others we have a little bit of a curve, and we'll talk about the difference between them. The second type of mathematical model, or graph, is a bar graph. And this is what compares the data collected by counting, or it compares different categories, such as types or brands. The information between the points, the bars, doesn't really make sense, so we can't make predictions. Here we have an example of a bar graph. We have types of cheese, so that's a category or a type on the x-axis, and the y-axis does have numbers. Remember, your y-axis will always have some kind of number. So what are some steps? Well, when you're looking at your data, it may not always be in order from the lowest value to the highest value. You want to make sure that you're keeping the data points together for when you're graphing. So really on the x-axis, what's the lowest to the highest number? So for example, if you have time, you would want 0 to 90 seconds. You wouldn't want your starting point to be 50 and your ending point to be 20. That doesn't make sense. You would want smallest to largest numbers. Next, you're going to determine the independent variable. This is going to go on your x-axis. Remember, the independent variable is the variable that's changed by the experimenter. I am changing the independent variable. Then you're going to determine the dependent variable, and that's going to go on your y-axis. Remember, that's the variable that responds to the changing independent variable. It's the data you're collecting, the numbers that you are going to be graphing. Next, you're going to look at the data. Careful, you only want to look at the averages. Most experiments have multiple trials, but nobody wants to waste their time graphing all of those extra trials. That's why we just look at the averages, especially if something may have gone wrong at some point. As you're looking at your data, you're then going to determine a scale. A scale is another way of saying how are you going to arrange the numbers on the line. You want to fill in as much of the graphing area as possible. It does take a little bit of practice. Make sure that you're checking your highest and lowest values. Your lowest value, that is where you really should be starting. In your highest value, you want to try and cover as much of the axis as possible. You don't have to start at 0 for a line graph. If your smallest value is 50 and your largest value is 75, you can automatically start at 50 and go up to 75, either by 1s or 5s, whichever is appropriate for your graph. You don't have to use breaks in the middle of your data. You want it to be continuous, especially because we're going to be hopefully making predictions based on our graphs. So there is a little bit of a general formula, a little bit of a hint for scaling. So if you take the largest value, your largest data point, minus your smallest value for that data point, and divide it by the number of lines on the axis, you should be able to figure out the scaling. For example, If this formula comes out to be 1.88, you can round that to 2. And that means each line on your axis represents a value of 2. Next, we want to draw the graph axes and fill in the scale values. Typically, the axes will already be there for you, so you're just filling in the scale. Careful, remember, the x-axis is your independent variable and your y-axis is the dependent variable. What I am changing is on the x, the data I'm collecting is on the y. Next, you're going to label the axes and you are going to include the units. This is very important for when we're going to be calculating slope, looking at a rate of change. You need a unit with your label. Otherwise, what do I know what those numbers mean? Next, you're going to plot the points. Remember, I only want to plot the averages. After that, if you have a line graph, you're going to draw a line of best fit, which we could also call a trend line, or a curve, whichever is more appropriate. So some things about a line of best fit. It goes through the middle of the data points. It doesn't have to hit all of them, or even any of them. Also, it doesn't have to start at 0. Some of your data points may be higher than 0, the first ones, so you don't have to start at the origin and draw up or down. Next, again, you don't have to connect the dots. And if your independent variable is time, you should connect the data points. So you do have to remember this rule. Time, connect, everything else, line of best fit. You're going to be filling in the notes on your, you're going to be filling in these graphs on the guided notes. If you double click on this image, it will actually open up to a drawing tool where you can add the lines as needed. We were just talking about using line graphs and when you should be using a line of best fit or a trend line compared to connecting your data points. So we will use a line of best fit when the independent variable is anything other than time. When your independent variable is time, that's when you connect your data points. So let's look at an example. The first graph I have, my independent variable is temperature of balloon. That is not time. Therefore, we would be using a line of best fit. A line of best fit doesn't have to start at 0. It doesn't have to touch any of the data points. You want it to be somewhat in the center of all your data. You will be using a straight edge. We can see that it only goes through one of them, but the other 4 data points are not being touched. Next, we have a graph where it's reaction time. So that is a measurement of time. You are going to connect your data points. Remember, you're going to be using a straight edge, so it may look a little bit better than what I am drawing right now. They show you very different things. They do show you an overall trend, but when you're analyzing your data, it's really important that you have the data points connected or the overall trend shown. Make sure that you filled in the graphs on your notes, then move forward. So if we're using a bar graph, remember we're comparing categories and something that you've collected or counted, you're going to make sure to shade in the bars evenly and completely. And I know that some of us would love to make them colorful and beautiful, like myself, but you want to use the same color, unless you have a double bar graph. Spoiler alert, we're not going to have many double bar graphs here in 9th grade. After that, you're going to give an informative title. A title is not a question. You want the reader of your graph to look at the title and know exactly what they're doing, not have to question it. So there's some general formats that are really easy. You can use the relationship between the IV and DV, just plug in your variables, or the effect of IV on DV. Notice neither of these are questions. Neither of these say IV versus DV. That doesn't give me enough information. You will not get full credit if that's what your title looks like. These easy formats, full credit titles. All right, so here we have a rubric as to how you're going to be graded on your mathematical models or your graphs. So the correct type of graph is worth 1 point. A title that's descriptive, includes the IV and DV and is not a question, is 1 point. Correct label on the X and the correct unit on the X are worth 1 point total. The correct spacing on the x-axis is worth 0.5, meaning you want to fill up as much of the axes as possible. Each line represents a value. You're not just putting your numbers scattered across. That's not appropriate. Same values for on the y-axis, so the label, unit, and spacing are worth 1.5 points overall. A line of best fit is used appropriately, or the data points are connected if it's appropriate, or the bars are, you have a bar graph drawn appropriately if it is a bar graph. It's neat and easy to interpret. So that means if you're using pen, nothing is scribbled out. If you have a line graph where you need to use a trend line, you've used a straight edge or a ruler of some sort. You can even use part of your agenda. You know, that's a nice straight edge. And also that the appropriate data is used for the graph. Averages only. Don't waste your time plotting all of the trials. Nobody wants to work that hard. You will be having some practice making graphs using your graphing practice packet. So please make sure that you bring that to class every day when you're here or have it readily available.